Hello everyone, we are gonna go over NumPy, which is a module, one of the modules that is being very helpful for the data scientist, data analytics community. So basically, this is a collections of objects and functions and properties that are very useful when you work with numbers and data, and that's what we're going to learn today. So let's get to it. So first of all, what is NumPy? NumPy, or some people call it NumPy, potato, doesn't really matter, NumPy, is basically short for number and Python. So it's basically a collections of items and like codes and function that allows you to work with numbers easier. So I sort of answer this question that I have posted here. What is a module? So basically a module is a collection of handy functions that are put together for later use. So you could also come up with your own modules and create that modules and let other people use it. So NumPy is one of those famous modules that are created by the data scientist community that are extremely useful. And if you work with any data, any number these days on Python, you will end up using NumPy. So a few things to pay attention before we start like running some very simple code is that when you write NumPy for presentation and talking about it, maybe it's better to make this a camel based. Make the P uppercase so it allows for the num and pi sort of be separated. But when you are calling a NumPy in your code, for example, you say import NumPy, all lowercase you will use. And also NumPy's older versions are called numeric or num array. If you came across these, try to avoid using them and stick with NumPy. And yeah, so let's get started with some simple lines of code. So the first thing you do is import NumPy to start working with NumPy. So you have to import these collections of code. You have to specifically say, here I want to use these codes. So you have to import it. So mind you, if you were not using Jupyter Notebook and Anaconda, which brings all these collections of programming tools together for us, we would have to install a NumPy as a module to our Python that we have installed in our computers. But since we are using Jupyter Notebook and Anaconda, this has already been done. So all we need to do, since NumPy is fairly, it's like famous enough module that everyone uses, it's already been done for us. So we only say import NumPy as NP. So one thing about this NP thing, it doesn't matter what you call it. This is your discretion. You can call this whatever you want. You can call this ABC. ABC. And if you do that, you can now get access to those collections by ABC. So it will run perfectly and it will work. But since everyone in the data science and analytics community use NP for the sake of consistency with the communities and with the codes that you might be wanting to share with other people or get some of the codes from the internet, we might as well follow this agreement that when we import NumPy, we import it as NP. So this just makes your code more readable for other people. So that's, now you have an array. So if I say, what is the type of my array? Do you remember the function type? Now I get, this is NumPy array. So I can access to my NumPy numbers in different ways. I can do it like a list. I can say row 1, row index 1, so row 0, row 1, and then columns 0, 1, and 2. So it brings now 7 for me. So I can access only to specific row. So I want the whole row 2, which will return all of those numbers. Or I can access like a matrix. One of the greatest things about NumPy is now that in Python, now you can work with numbers in matrices. So before, if you did not have Python, if you wanted to like work like matrix, you were not able to. You would have to like sort of create list of lists, and if you wanted to do some operations on your matrices, you would have to jump through hoops for creating those programs and codes for yourself. But NumPy has done all of those things for us. So if I run this, I will get the index 3, index 3, 0, 1, 2, 3 row, and index 2 columns, 0, 1, 2. So I will get number 15. And also what we did here, we could do with, like a matrix. We can like treat it like a matrix, and it will give us the same answer. So before we move forward, let's take a look at 3 advantages of using NumPy arrays over lists. So first of all, it gives us better accessibility. While I can, have concept of slicing on columns or lists for Python, for NumPy, such as I want to get all of the rows but only for columns too. So I want to get all of these 3, 7, 11, and 15 numbers. This is for any reason. This is a matrix operation. I want to get access to these values. I can do that simply in with NumPy array by just using colon, which signify I want every row. Or I could be saying I want every column for a specific row, which would give me all of those numbers as well. So we have column and row complete accessibility to the data or to the numbers. So let me make this back to go to what it was. But if we were to do this with a list, the list would give us an error. It does not support that sort of operations. So that's a very good advantage, very important advantage of NumPy over the list. With NumPy, you can also do operations on the matrix, but you cannot do with array. So if I want to multiply all of the numbers in my array by 2, I can simply just do that. But with list, if you do that, it will give us, it will multiply the list by 2, or sort of like add another list to the end of the list, which could be useful. But basically, this is not what we want when we want to treat those numbers like a matrix. Or you could, if you were to do multiply by 2 all of them minus 1, you still can do that. But if you did this here on my list, it gives you an error because you cannot do operation -1 for your list of lists. The last advantage that we will go over here is the fact that with NumPy array, you can map a function to all of the numbers in a matrix, but you cannot do that in a list or list of lists. So for example, if I say map this lambda function of a square of all of the numbers to my list, it will give me an error of saying can't multiply sequence by non-integer of type list. So list does not even accept these types of operations. But NumPy has a very useful function, Vectorize. You basically say np vectorize and you pass on your lambda function, and it creates a function that is ready to apply for any matrix or any function. So once I run this, now I have vectorize function. Now I can pass my array and say v function, and it does the trick for me. I can score function to all of the members of the matrix. One other thing that is very useful in NumPy array is comma slicing. Basically, comma slicing gives you the opportunity to get every yth element at x position. So that start from x position, you want every yth element to be sliced out of your array. So for example, if I create an NP arrange, which is basically an array from 0 to 19, and I want from position 1, I want to get every third element. So position 1, 0, 1, I want to get every third element. So I get 1, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. You see, 1, 2, 3. 1, 2, 3. So I get every third element. And this is very useful, of course, in case for some reason you need to slice these numbers out in a real life data analytic problem. So this is another feature of NumPy array that is very useful. One other thing that is used very often with this type of slicing is ::(-1) slicing. This basically means I want my array to be reversed. So if I say A, ::(-1) basically means from the beginning I want every -1 element. So from the beginning, which is here, I want every -1 element. So -1 goes back. So I want this, and then I want this, and I want this, and I want this, all the way to 0. So it reverses the whole array for us. So please remember, if at any point in time you wanted to reverse your sort, this is your trick that you can use. ::(-1). A few useful functions here. The first one is arrange. Basically, as we use it here, basically you get the values from 0 to n-1. So 10 minus 1, 9 in the range. So you create that list or array of numbers from 0 to n-1. Or you could start from desired numbers. You can start from 5 and then all the way to 9. Or you can also specify that you want the floating points instead of the integers, and it also does that for you. Zeros, the function zeros basically gives you collections, an array that all of the members of it are 0. You just need to specify the structure of the array you want. So I say 10. It means I want 10 numbers of 0 to be created. And these types of functions are very useful when you need a placeholder to do some calculations in a loop or something, and then once you get to that point you want to put something here. So you sort of create that placeholder and then you update that with the number you want. The same thing here. The only difference is now you want the matrix, all of them are 0. The same thing with ones. Instead of putting values of 0 there, it puts values of 1s. So all of them are 1s. And you can specify you want integer, and it removes the floating points. So it specify that they are integer. The last function we'll go over in this video is Linespace. Linespace is basically a function of NumPy that allows you to create numbers from a starting point, ending point, and have the increments from this starting point to the ending point. So for example, here I want to have 100 data number points or data points that start from 0 and end with 1. And the way it calculates it, it says, okay, I want from 1 to 0, 1 minus 0 divided by 100. So this is the increment of that number. So once I run this, now I can see that I have 100 data, and it starts from 0 all the way to 1. So if I were to say 101 here, now I would get the cleaner from 0, 1, 0, 2, because now I have 101 number. So that's how you want to think about this. This is how many numbers I want, and from when I want it to start and from when I want it to end. Some useful way of using Linespace is if you want to do a fast calculations of an equation. So for example, I want to solve for x in this equation. 3x power to 5 minus 2x power to 2 plus 100 is equal to 0. I want to find that x that makes this 0. So one thing I could do is to create options and say I want 201 possible options from -100 to 100. And for all of these options with a loop, calculate that equation, calculate that statement. So once I run this, very quickly it calculates all of the possibility. Now I can just like scroll down and find at what point this number of the values. So it approaches 0 around between -2 to -1. So now that I know the range of the answer is between -2 and -1.8, I can simply put that here and run this, and now I can have like a more accurate answer. So I scroll down, I see the value of 0 has been reached on -9.83. So this is the possibly -1.8365 is a good estimate for this.